Hello students, in this video we'll look into the next topic of laws of motion, that is normal reaction and tension. Now what is normal reaction? A force acting perpendicular to two surfaces in contact with each other is known as normal reaction. So why is it called normal reaction? Because it is acting perpendicular. Now you can see in this figure that is shown here. Now the force mg is acting downwards and normal reaction offered by the surface is acting upwards. This is the surface. So when an object is placed on the surface, normal reaction, see this object is in equilibrium. So I can safely say that normal reaction equal to mg. So if an object is just placed on a horizontal surface, then normal reaction is equal to weight of the object. Now let's look at situations where I apply force on the object. So next case what I do, let's say I have something like this, a surface, and I keep a block on this, mass m. I apply a force F on this. Then normal reaction offered by the surface in the upward direction. So what is the net upward force? Net upward force is N. What is the net downward force? F plus mg. So in this case, what is happening? Normal reaction would become F plus mg. Now let me take a situation where force is applied in the upward direction. I tie a string to this mass and try to pull it with the force F. Then what will be the downward force? Downward force is mg, and normal reaction is acting upwards. So I can write N plus F equal to mg. So what will be normal reaction? Normal reaction would be equal to mg minus F. So this expression is only valid when F is less than mg, because once F is greater than mg, there would be no more normal reaction. Normal reaction comes into picture only when there is contact between the surfaces. Now let me take a situation where a force is applied at certain angle. Let's say this is mass m. I apply a force F at an angle theta to the horizontal. Then this part would be F cos theta and this part would be F sin theta. Now what is the downward force? Weight, and normal reaction is upwards. Again I equate the upward forces to downward force. So from this what do I get? I'll get N equal to mg minus F sin theta. So in this case normal reaction is mg minus F sin theta. In this way I can find normal reactions depending on various situations. Now let's look at a situation where I want to find what is normal reaction on an object which is placed on inclined plane. Now I can see that weight is acting downwards. So I'll find the components of this weight. So if this is theta, this is 90 minus theta, this would be theta. This would be mg cos theta and this would be mg sin theta. And Fn is normal reaction. I'll write to there. So because the object is not moving perpendicular to the plane, I can say the net force perpendicular to the plane is 0. So I can write N should be equal to mg cos theta. So what is N here? N equal to mg cos theta if there is no other force acting on an object which is placed on inclined plane. Now the same thing, if I apply a force F, let's say something like horizontal, like I apply a force F in this direction, the second case, then what will happen? Let's find out components of F. This is theta, this is 90, this would be how much? This would be again theta. So this part would be F cos theta and the component of F in this direction is F sin theta. Now I'll see that a component of F is also trying to push the block down. So in that case what will happen? Normal reaction would become F sin theta plus mg cos theta. So in this way, if I'm having any other force other than gravity acting on an object which is placed on inclined plane, I find the components of that force parallel to the surface and perpendicular to the surface. The component perpendicular to the surface would contribute to the normal reaction. So after that, let's look at normal reaction on by a vertical surface. Now if there is a vertical surface and I'm keeping an object, that means I have to apply a force on this. If a force is applied on this, then because this object is not moving perpendicular to the plane, net force would be 0. Normal reaction is like this. So I can directly say normal reaction equal to the force applied perpendicular to this. One important thing that you have to see here is, here weight or frictional force do not contribute to the normal reaction. Why? Because they're acting parallel to the surface. So normal reaction only acts perpendicular to the surface, and only the forces which are acting perpendicular to the surface would contribute to normal reaction. Now let's look at the next situation, that is tension in the string. So what is tension? Tension is the pulling force that is transmitted actually by the means of a string, a cable or a chain or a similar object using which we try the mass. So the easiest way of understanding tension is I hang a mass M to a ceiling. Excuse me. So if I'm hanging a mass M to the ceiling, what is happening? Mg weight is acting downwards, then tension T is acting upwards here. Similarly, on the surface, tension T, this rope is pulling the surface down and the surface is pulling it with force F. So let me see, these two are stationary, are in equilibrium, so I can write T equal to mg. So these two forces are again in equilibrium, so I can say T equal to F. So from these two, what I can say, F equal to mg. So what is happening here? Who is applying force on the mass? The string. Who is applying force on the string? The roof. So in this way, the roof is applying force on the mass through the string. That force is transmitted through the string in the form of tension. Now let's come to an example where I have a force applied on a horizontal surface. So let's say this is the tension acting on this is T. So again, tension here, if a person is pulling it, let's say like this, right, with F. So this is moving with an acceleration A. So what is tension for this part? I can write T equal to ma. For this part, what I can write T equal to F. So from this, what I can write, F equal to ma. So force is applied on the block by the person through the string, and the string carries the force applied by the person to the block in the form of tension. So in this way, I can see tension in case of an object which is placed in horizontal surface or in vertical surface. Now let's look at some situations where we have multiple ropes. Let's see here. Now I have a mass M or a weight W which is hung to a pulley which is massless, and we have a massless string which is making a loop. Now tension in this part would be T, tension in this part would be T. So what is the net upward force? Net upward force is 2T and downward force is W. So what is tension here? Tension can be written as weight by W. So if the number of strings increases, the total force applied would be shared by all the strings. Now let me take another situation where I have more number of strings than this. So let's say I have something of this kind, right? All pulleys are massless, all strings are this. Also massless. I have a mass M hanging to this. Now there are 4 strings upwards. So what will be the total tension? 40 upwards. What is the weight? Mg downward. So I can write 40 equal to mg or T equal to mg by 4. So in this way, I can find tension for multiple systems also, right? Now let's look at another situation. Now we have, two masses M1. I'll say this is M1 and this is M2. Uh, M1 and M2. Let's assume that the masses are in equilibrium. Now what is tension? If the string is same and everything is massless, tension would be same everywhere. So I'll say this is T1, this is also T1, this is also T1. Now on this part, what is the weight that is acting downwards? I can say M1G is acting downwards and T1 is acting upwards. So I can say T1 equal to M1G. Now let me come to the next part, M2. The downward force is how much? M2G. And the upward force is how much? 2T1. So I have 2T1 equal to M2G. Or T1 would be equal to how much? M2G by 2. If the system is in equilibrium, what I can say, M2G by 2 equal to M1G. Or I can say M2 equal to how much? 2M1. So I can find the ratio of the masses from this situation. Now sometimes I can have a situation where I have normal reaction as well as tension coming into picture. So what kind of situations are those? Let's say I have a pulley, and a person is holding the pulley, holding the rope at one end, and standing on a floor, and there is a mass M hanging to the other end. I'll say this mass is mass of the object, mass of the person is MP. Now if this is an equilibrium, then mass of the object into G is acting downwards, tension is acting upwards here. Similarly, tension is acting upwards here. Now because this rope is trying to pull the man up, the net normal reaction of the man will decrease. So what is tension? Tension, I can write mass of object into G. Now coming to normal reaction, mass of person into G is acting downwards. Normal reaction is acting upwards. Tension is also acting upwards. Mass of person into G is acting downwards. So what will that imply? Normal reaction equal to mass of person into G minus tension. So that is mass of person into G minus mass of object into G. So normal reaction would be equal to how much? G into mass of person minus mass of object. That means, when a person holds, or when an object kept on a floor or other surface is connected to the strings and there is tension in the strings, then the tension in the strings would also affect the normal reaction on the surfaces. Now let's look at another situation where we have two strings tied. Now two strings are separately tied, so the tension in both the strings will be different. Now let me find out what is T1 and T2. So what is the weight due to this? mg downwards. This is T2, then if it is making an angle theta, this would be T2 cos theta. And the upward would be T2 sin theta. I am finding components of T2. T2 is acting like this, T1 is acting like this. Now, because the system is in equilibrium, vertical forces should balance. So T2 sine theta should be equal to how much? Mg. So T2 would be equal to mg by sine theta. So we got T2. Now let's find out T1. How do we find T1? The horizontal forces should also balance. So I can write T1 equal to T2 cos theta. Now what is T2? T2 is mg sine theta, or mg by sine theta into cos theta. So from this, what will I get? T1 equal to mg cot theta. So in this way, I can find both T1 and T2. So this is the various ways in which we can analyze tensions, and tensions helps us to find out various other parameters. So this is what is there in normal reactions and tensions. Hope you could follow this. Thank you very much.